have to the fork and exe. Though one of the reasons why we have the thread is the fork and exe also require a lot of computer resource. Takes a long time. Okay? That is the reason if we can make the thread that is much faster. So we can separate the schedule. So I'm going to skip this part. In the text also, we are not going to discuss detail for each thread, the scheduler, but it is based on the previous scheduling algorithm, but each processor should schedule such a thread. So it has a thread scheduling structure. So this is the API to schedule the thread. So using that API, you can schedule such a thread. What about the multiple processor, which means we have the multiple CPU? Do you have the multiple processor laptop? Nobody will sit on this chair later. Okay. It's your bad day. Yeah. Okay, so what is anyway, you sit on the here. So what is do you have the multiple processor laptop? Yes. Then what happened? Are you doing any special things? Probably not your operating system, right? So there are different types. When you have the multiple processor, there are different types of computing architecture. It's not a problem of the operating system. It's not a problem of the network. It's a problem of computer architecture, especially for distributed computing. Okay? So in terms of such a distributed computing architecture, there are different ways of the architecture to support the multiple processor. One is you can consider such each processor as exactly identical. So homogeneous processor. Homogeneous processor means is within multiple processor is exactly same. Okay, so doing same thing. It's nothing different. On the other hand, asymmetric multiple processing is each processor has their own, okay? Its own data structure, and they need to share other, okay? However, these are more complicated nowadays. Logically, they have seen the one processor. Do you consider in your programming this processor or this processor differently? No. So just one looks like the one, but it has the physically multiple. That is called SMP, symmetric multiprocessing, symmetric multiprocessor. The other is sometimes called the MMPP, or the shared nothing, shared everything, but you don't have to worry about in this class. Only the SMP. SMP is the logically it looks like the one, but physically it's a multiple processor. So each processor has their own scheduling algorithm. Why? Because anyway, even though it's logically one, but physically separated, each processor should process different thread of the instruction. So each one has their own. Okay? And this one, their own, each processor manages their own ready queue. Okay? However, who is in charge of to assign which processor this processor is in? Operating system schedule. Okay? Depending on how to assign it, there are two types of the affinity. When operating system assign the process, soft affinity means I try to best. For example, this processor was the last processor that processed this process A. We do better assign this processor A to this processor. Why? Because it has been executed here. Cache data or the add to cache or memory cache, such a cache data may be there already. Right? Even though all the information, register information or cache information copied to the PCB, but still there might be chance to reuse such a data. So we'd better assign the process the previous processor CPU. However, we cannot guarantee it because this one is already used. I need to assign this process A to another processor. Try to my best. That is the software affinity. We cannot guarantee. However, if you stick on only the same processor, okay, that is a hard affinity. So there is one more process in SMP. You need to assign the process for each processor. Then each processor will process schedule the number of processes using the CPU scheduling algorithm. Okay, then you don't have to worry about it. The problem is you wanna get full benefit of multiprocessor, right? That is the problem of what? Parallel programming or distributed programming problem. Okay? So it's not the scope of the operating system, but if you are taking the advanced level, like a distributed operating system, we need to talk about such an issue more in detail. Okay? So if you do not satisfy with your multiprocessor, next is you. With such a, I expect 2 times of the performance when I purchase the dual CPU, but we cannot get because your programming, your operating system should support such a parallel process.
Can you explain the soft affinity again?
Soft affinity is in general. Okay. Hard affinity, you need to wait. If this one is always busy, but you stick on this processor, you need to wait. Okay. So soft affinity is in general.
So you said that who is going to decide that who will take the schedule?
Operating system, there is a separate process. Okay. What is a Newman? Ever heard about the Newman? Not human. Newman is non-uniform. What is this? So memory access. Okay, which means it's the distributed database, distributed computing architecture, one of the distributed computing architecture. So CPU can access any the memory. So if you separate this one, okay, in the computer we have the CPU, we have the memory. Shared nothing. Okay? This is the easy problem if this CPU update the data. So you are running the two exactly same program to get the parallel processing, benefit of the parallel processing. Okay? So you run the program A, so like the finding the prime number. Finding prime number. So it finds the new prime number 5. But it still works because this process does not know whether 5 is identified, calculated. That is the shared nothing. So shared nothing is good for if the job is separated. For example, this one is 1 to 10,000. 10,000, 1 to 20,000. Finding the prime number. Then they don't have to discuss each other, right? So at that time you can get the benefit of such a parallel process. But not all the algorithm, it can be divided, segmented. So to address that one, we can access other memory. That is the non-uniform memory access computing architecture. It's called the NUMA, which is nowadays very popular. Okay? At that time, what can be the issue? What can be the issues of the NUMA, the CPU scheduling algorithm for such a computing architecture? You need to also consider, usually accessing the local memory is faster than the other, right? So yes, it's true. So that means you need to consider memory access algorithm in your CPU scheduling algorithm. It's much more complicated. Okay, so that is the reason such a multiprocessor. It's not actually the easy computing architecture. Sometimes you cannot get the full benefit of the multi-core multiprocessor. This multi-core has the same issues. Okay, that is the CPU scheduling issue in the multiple processor. In other words, we do better. Our goal is if we can balance the load, the job, that will be the best one. But such a load balancing is not easy. There are a couple of solutions to keep the balancing of the load, which means one is push and another one is pull. As name implies, push means push. But doesn't mean pull. Yes, he's a genius. So if that processor is busy, you can pull that job. That scheduler looks like the busy, then you can pull. Push means you are busy. So he looks like the idle, so you can push it. So you can communicate through the push and the pull migration between the processor, between the schedulers. Okay, that is for the load balancing. Multi-core process, it's the same issues. Okay, I'm going to skip that part. In the what is yes?
Multiprocessor and multi-core are two different things?
Multi-core. Yes, we are talking about the multi-core. The multi-core has the same issue as a multiprocessor, but slightly different. So I'm going to explain that different part.
But I mean, when you say what multi-core, what one core means?
Multi-core is what is the core? Multi-core. So you have is there any the multi-core? Most of the right now the computer is a multi-core computer, dual core, quad core, 8-core. Is there any other 16-core? I don't know. So if you have the PlayStation 3, it's an 8-core, right? So IBM chip, actually the power chip used in the PlayStation is one of the best, the CPU. Really, that's the 8-core, the processor, and then it's a very fast in terms of the processor power. Anyway, so multi-core means multi-CPU is separated. It has its own add-to cache or the CPU cache, and it has a CPU. It's separated. Okay. Then they are connected to the motherboard. Okay. It connects to the memory. Multi-core system is within the same chip. Okay. It processes the multiple thread. For each bar is on the same chip and it shares the cache memory. So benefit is power consumption is much less than multiprocessor. One of the issues in the computer is, my computer especially, is if I watch the movie, it will be turned off automatically 20 minutes later, because when you watch the movie, a lot of CPU bounded job, so calculation, and also the I/O. Okay, so it's very hard, so it cannot actually resist such a high. So still works on the low power consuming the computer architecture. So did I mention one of my friend? I met the old friend at the conference last December. So it's after 32, 33 years later. So after we graduated from the elementary school, but I can easily recognize him because he has the very. Is there any specific name of the chin? So I can easily recognize him. But what he's doing is he's the designer in the IBM, the Austin is a power. He was designer of the power chip. Right now, he is working for it's still IBM, but he is working for the designing the grid, power grid for the New York City. You see any relationship between the designing the power chip, the computer, the chip processor, and the city architect in terms of power? Okay, what he was doing in the power chip, the designing group, he tried to design the power chip processor that need as less power as possible. Okay? Which part used more power and try to connect to each other, something like that. That problem is exactly same as the New York City design. Like the Manhattan, which area used more power? In case of power down, how can you support? Okay, so that means the power consumption is a big issue in the processor design. Anyway, so at that time, the multi-core system has what is the computing cycle? Computing cycle is using the processing the thread of the instruction, and it consists of another memory store cycle. It takes some time to access the move data from memory to CPU. That is called the memory store cycle. So it looks like the same as the CPU-based CPU scheduling algorithm. So by changing interactive, so when we have the multi-core system, we do not put together. Instead, when the one thread access the memory, we will activate another thread, another core, okay, to process the instruction, then access the memory, okay, so we can actually compensate each other iteratively fashion, so we can design the scheduling algorithm by considering this one.
What did you say, computer cycle? Computer
Just processing the instruction.
One instruction?
Yes. Any question? Do not ask more. That's all I know about the multi-threaded multi-core system. Good student. Next one, what is a real-time operating system? I've already asked the question before. What is a real-time system? Last time, the guy who sit on this one is over there. Now you understand why he's there. What is a real-time system? What is a real-time system? I asked you before, right? No? Please calm down. I like it. Real-time system does not mean the fastest system, right? Real-time system means guaranteed, okay, manageable. Like the nuclear plant. This is the time. I'm not sure when is the first anniversary of the East. There was a big earthquake in Japan, and it attacked the nuclear plant. It's still the problem. Okay, which means if there's something the leak of such a nuclear or the chemical, so it should inform within certain time, right? Kind of deadline, very important deadline. So if you have the scheduling that should meet the deadline, that is called real-time operating system, and that real-time operating system is real-time CPU scheduling. It's a guarantee. Meet the deadline. Okay, reach the deadline. That is a real-time scheduling. There are two types of real-time, soft and hard real-time. Yes, what is the soft real-time?
It should respond within quickly or something like that.
Agree? What about the hard? to meet, it tried best, but sometimes fail, maybe fail. Just try. Best to meet the deadline. But we cannot guarantee 100%. It try, but not guaranteed. On the other hand, hard real-time means must. Okay? No matter what happens, it must the deadline. That is the real times, the CPU scheduling. Always there is the latency. Two types of the latency that affect the real-time CPU scheduling. One is the interrupt latency. So operating system itself is interrupt based, which means the interrupt means the other process. I want to do something, stop the CPU, then start it again, resume. So there might be the time, the delayed time. That is called interrupt latency. For example, one of the examples of such a latency is context switch. What is a context switch? Between context? Yes, context of what? Process. Yeah. Current process, context of the current process to the another. So that is the, we need to consider such a delay time. Another one is dispatch latency. Dispatcher means scheduler to decide. It will take a time to decide which processor. Because of this latency, it's not easy to guarantee the deadline. So there are different the approaches to make the real-time operating system real-time. Okay. Next class, we will continue the priority-based and other. Today we are going to have the second invited speaker in Engineering 400. So if you are taking that course, you need to must attend, you need to move quickly to that Dana 107. Otherwise, it's welcome to join. Okay? Any question? Okay, thank you. And